Alright, this should be recording. Doing this recording for a place called scienceforums.net, where I'm going to attempt to post a comment attempting to provoke some sort of rational conversation about the possibility that conventional physics may have an incomplete understanding or theory regarding interference of waves, specifically photons, and their claim that they are behaving like they were part of a medium of connected substance, like water, or the other things they would compare it to create this idea of a wave function, and that there is an alternative explanation. There are perhaps many alternative explanations that may be quite reasonable and quite possible as the true explanation for the cause of the phenomena known as wave interference, the simplest pattern you can create in the universe, an on and off pattern. So anyway, this specific video will be on the radio interference, and it comes in two forms as it's taught in mostly MIT. I've seen it. They have videos from the 60s, and they have videos in the 2000s. So 50 years of making the same kind of argument that you can reveal wave interference, or the fact that photons are some kind of wave, by doing this experiment with two radio transmitters with the same signal on them. Now you can either use radar, or you can use bigger antennas with a bigger field to do the experiment in. I've seen it done both ways, and it's always done with a carrier signal, a sound signal put on the carrier, and the experiment is done showing that you do not receive the signal in certain locations that would be consistent with where the signal is out of phase. And the assumption is that the waves interfere with each other, create destructive interference, and somehow the energy is destroyed, and there is no signal, there is no energy received by the antenna at certain locations. And alternatively, that energy that should be in those locations is somehow jumped to some other location, which I don't think has either been proven. I would argue that it just depends on how you understand frequency. So if you understand it to be quanta of energy at a distance, a wavelength, then you can understand that when you impose a secondary frequency, oh, sorry about the effect. Yeah, I left it on. It is cool. I like it. Sorry about that. Yeah, I'm not going to fix it now. So when you have two frequencies, and then we'll just use them this way, so you can understand the two bits are just recognizing the quanta of the energy separated by a distance, and the quanta of the energy separated by a distance. And when you take two signals and put them out of phase, you create a new frequency. And as I will assume most of the people listening to this video understand, we can't detect signals without tuning to their frequency. And when you double the frequency, that's a substantial difference in the frequency, and therefore it makes perfectly good sense that they would not be able to receive the signal. So I did type up this basic text. I won't reread it. That's what I'll post is my post. Simple, to the point. This is the board I'll attempt to post it on. And what I'll attempt to do is a quick drawing just to illustrate the basic argument. And that should do. Yeah, so the idea is, let's see if this works. Sorry, this is the first time I'm using this particular mode of videoing, trying it all in the browser. So you have two antennas, and they're producing the same frequency and the same wavelength. And the frequency has an audio signal placed on it. Well, it's almost in the picture. Almost. And so the idea is that you detect the signal in this field, and at certain locations you'll get a signal, and other locations no signal. And I would argue that the simple explanation for that is that the two frequencies, again, are just photon on, photon off. So both antennas are just producing a ton of photons, and then no photons, then a ton of photons, then no photons. That's the basic frequency. And when they are received out of phase, it just essentially means the signal that the antenna is receiving is going to be twice that frequency. And because the receiver is tuned to this frequency, it will not receive this frequency, the one that has been created in these locations. But all these locations are receiving exactly proportional to their distance, of course. They're obviously, the further out you go, the weaker the signal gets, the longer the distance from the antennas. But they're all receiving, you could say just as, you could draw it as just a, well, that's not in the drawing. Well, anyway, that is just a proportional curve. And all of these locations have signal hitting them. There is no interference. There is no photon plus photon equals no photon. The same number of photons are hitting all these locations. At least the same number are hitting here that are hitting here. And there's no, nothing's happened in this field that's created new universes, and there's no wave functions. It also challenges the whole theory of quantum mechanics, where we are to understand that the phenomenon of interference is something that happens to single photons. That single photons somehow break into a wave function, and the wave function interferes with itself. And this experiment would argue that no, individual photons, uniquely different photons, can interfere. And so it bends the rules of quantum mechanics quite a bit in terms of creating this new argument that not only do photons split in two and create two wave functions, they can also not split in two and still have a wave function that they can interfere with each other, even though we can't make them do that in most other common experiments where we don't have, where we haven't engineered the experiment to produce the result consistent with the theory. So I would argue this is simply radio jamming, signal jamming in both cases, whether you're using megahertz signals at 40 meters or you're using radar at 2 meters. It's just jamming the signal, and you can't receive two radio stations of the same frequency at the same time. And essentially that's what the receiving antenna is seeing, is two stations at this, broadcasting the same signal out of phase at the same time, and it's just impossible for the receiver to amplify more than one frequency at a time, or more than a narrow group of frequencies at a time. And unless you're specifically looking for just the amplitude of the energy hitting the antenna, unless you're measuring that, you won't realize that the signal is still there, that it hasn't been destructively destroyed, and that you're just not properly tuning your device to the energy that exists. That should be enough. So, thank you for your attention, and that's case number 1, and we'll see if I'm allowed to make the other cases that I think are also challenge the incomplete and bizarre theory of conventional physics.